Why don't you guys come on in the shed? We're going to show you the power system. We're going to show you what we've got done so far and give you a flow, if you will, and some explanations. So come on in. Alright, so as you've seen in the several parts you've watched so far, we've gone here, we've got our modules mounted up the way we wanted, we've got the wire in, conduit buried. You saw where we mounted the AC wiring. So basically what happens here is we have a battery based inverter, we have a set of batteries that we'll show you in a second, we have some charge controllers. So what happens here, this panel is fed from the utility, and then this panel is fed from the backup inverter. So when the grid fails, the utility fails, the inverter will automatically start powering this panel from our battery bank. So this is, like I said in the prior video, a hybrid inverter. So it will sell to the grid when it has excess, but it will also power the house off grid when there is no grid. We have a Midnite E-Panel down here, Schneider XW PRO. You'll notice that we do have the gateway so we can see it from in the house. We do have the system control panel, and then we do have microinverters like we talked about. This is one brand of microinverters we have. We have some Chilicon microinverters. The other one is AP Systems. We'll try to pull that up on the cell phone. So you can see there, that's we'll find you power. That's what those are doing currently. And I will pull up the AP Systems on my phone and show you what's going on there. The AP Systems micros don't have a web interface like that. You have to pull it up on your phone like this. You can see they're doing 2600 watts. And then we can go to module view and see what the modules are doing. So there's what our AP Systems micros are doing right at the moment. You can see those are in the sun, these are more in the shade. So as we move over, what we have here, we have our classics, Midnite Solar Classic 200s. We have a battery combiner box. Normally you might not need one of these, but in our case, we have a lot of different types of batteries we're playing with. So what's happening here is this is your battery positive bus bar. This is your battery negative bus bar on the battery side of the shunt. This is your battery negative bus bar on the load side of the shunt. You'll notice we've got a Whiz Bang Junior on there talking to the classics, so we can monitor all that. And then what we have is we have an individual 175 amp breaker. We have one for each string of lead acid batteries, and we have one for the Fortress battery. And as we add like the Midnite lithium batteries, we'll put another breaker in for that. And that way we can turn one off and then turn the other one on, and there's no interaction between the two. We do put lockouts on them so we can lock the breaker out when we're not using it. And then we have a 175 amp breaker over here that's feeding two bus bars up here that are just for our charge controllers. So a lot of the reasons we did what we did, we could have put the charge controllers on the side of the E-Panel and it would have handled two charge controllers just fine, but we know we're going to be testing a lot of new Midnite solar charge controllers in here. So by doing this, we have high current up here. We have 175 amps of battery capability up here, and all of our PV comes in down here. So we can reconfigure for low voltage or high voltage and feed 600 volts to a charge controller. So it just opens us up to do a little bit more testing and, you know, the flow of things. So essentially what happens is the PV is coming in this conduit, the solar modules. It's going through the breakers into the Classic, back out of the Classic through the breakers into the bus bars, from the bus bars down into the battery combiner, and then from the battery combiner it's going over to our batteries. And we will be building a box around this. This wall is going to get, we're going to finish plywooding this wall and sheetrock this wall so it's a little more fire resistant as we test equipment, and we will be venting the battery bank outside. So this battery does have to be vented. We'll put a power vent on it running from the Classics. The lithium does not need to be vented. So that's kind of it in a nutshell. We'll go ahead and we'll get the covers on. We'll give you a view of this after the cover's on. You can see how neat it looks. But essentially, you know, this is what it takes to do a battery-based grid tie system. You need a set of batteries, you need an inverter, you need some charge controllers. Now, as you saw with the monitoring that we showed, I don't have a microinverter with me, but I'll have one here when we put the covers on, and I'll show you. They basically go up on the roof with the modules. They wire into one of your AC panels, just like a regular AC load, and you're done. Very elegant. The problem with that is when the grid fails, you have no power. And around here where we're at, the grid fails a lot. I would say, yeah, no, it's not necessarily down more than it's up, but it's close. So we really do need battery backup. We want battery backup. We even have the microinverters set up to AC couple. So the XW Pro does a great job of AC coupling, and what it does is as the battery voltage gets too full, it will raise the frequency or lower the frequency. I can't remember which one the Pro does, but it changes the frequency anyways of the power that it's putting out. So instead of putting out 122, 40, 60 hertz, it may go up to like 61.5 hertz or whatever that number is, and that knocks the microinverters offline, and they quit charging the battery to prevent them from overcharging. So it's a pretty elegant solution. We have a lot of PV out there that's grid tied, so we only have half of it able to AC couple, because even in a grid down situation, we still have, I think, about 7,000 to 8,000 watts on charge controllers, and then we have another 5-ish thousand watts that we can AC couple real quick. So we can pretty easily hit these batteries with 10 to 12 kilowatts of solar modules when the sun is out, the way the system is set up. So that's way more than like the lithium or the lead acid can handle, because they're not a huge battery bank. Our batteries are basically sized to go one 24-hour block with no input, maybe 1.5, 2 days, depending on how conservative we get. We're really counting on some solar gain during the day, and we're also counting on most power outages to be short. Although around here, to be fair, in the winter they usually seem to last 3 or 4 days. So, but the system works great for that. So yeah, that's pretty much it in the power shed. We'll be bringing you back and showing you with all the covers on, and just kind of running through all the products one last time to recap what each product is. We'll also be bringing you in as we start hanging equipment on the wall. We start getting the new Midnite Barcelona or Hawke's Bay, or the new inverters from Midnite. We'll be hanging those on the wall. We'll be going through those, seeing if we can blow them up, let the smoke out of them. We'll have a lot of fun with those, so we look forward to that. So hold on, we're going to get all these covers on, and we'll come back and we will give you a recap of what everything is. Alright, so we're back. We got the covers on everything. We're going to just do one run through around a circle around the room. So as we recap, we got our AC distribution panels, 100 amp panel fed off a 50 amp breaker to the system from the utility. This is another 100 amp sub panel feeding the loads from the system. We have our Midnite MNSPD-300-ACs, one on each panel. We also have a thermostat and an outlet, with the bottom half of the outlet is switched, and we have a small 1100 watt oil filled heater out here. So this keeps the building about 45, keeps it above freezing. We have a smoke detector that is interconnected with all the smoke detectors in the house, so if there's an issue out here, it'll let us know as soon as possible. And then we have a backed up receptacle where we plug in everything like our internet and our gateways. As you saw, there's a router, a hub, the gateway, the system control panel, the Chilicon interface here, and then our E-Panel, which we'll go ahead and turn the inverter on. Okay, we've got our E-Panel, Schneider XW 6848 Pro. You'll notice we just fired this up, so it's qualified the grid. It's counting down its 300 seconds before it can sell to the grid. So then that will start to sell to the grid. And as we turn the corner, as we talked, we have our Classics by Midnite. We have our MNDC15, which will hold up to 15 panel mount breakers. Nice place to work. Our battery combiner box with a 1000 amp shunt, so the Whizbang Junior talks to it. Alright, and as we told you, we promised we'd go get you a microinverter so you could see. This is the AP Systems YC600. Probably one of my favorites. I have no affiliate with any of the microinverter manufacturers, but it's a nice, robust, heavy product. This one does 2 modules in, and has an AC plug on the end of it. So when you buy these inverters, your distributor will ask you what you need. You'll tell them how many you're buying. They'll send you the right cord for this, and these just plug into a harness. And then at the end of the harness, you're going to have your regular black, red, white wires like you would if any 120/240 branch circuit, and those just connect up to a 120/240 breaker in your load center, 20 amp breaker. I believe you can do 7 of these per trunk back. So if you had to do a lot of these, you could run, you know, a combiner up on the roof, an AC combiner, and feed it with a higher current. But if you're doing a solar system and your only goal is to do you know, utility cost reduction, then microinverters make a lot of sense. Purely grid tie makes a lot of sense. It doesn't add the cost of all the equipment we've shown you and the batteries that we will show you. You know, if you go to your favorite distributor, and you can look online, just search for solar equipment online. Search for AP Systems YC600, for example, or Iron Ridge Rack. You know, you look at some key names. You'll find a lot of distributors that sell that. I'm not going to name them here because there's way too many to name. But just do a search, find where you can get a good price, find somebody that will, you know, help you design the system you're trying to do, and you buy that product. And if you can install it yourself, for the most part, even if you have to hire an electrician to come in and do the interconnect, you're probably going to have a return on investment of, you know, 4-ish years on something like that right now, with the cost of solar modules being where they are. They're very affordable right now. So that's enough on the micros. We have our Fortress Lithium, and then we have our Trojan L16 REBs wired up in 2 strings of 48. Each string goes back to its ohm 175 amp breaker back here in the battery combiner box. So if there is a short, or if we need to isolate one string for whatever reason, we can do that. So that's kind of a tour of the building. We look forward to getting some sheetrock on this wall and getting some of that new Midnite product in here, and seeing what we can do, seeing what we can break, what we can not break, you know, and how it all performs. So if you have any questions, you know, leave them down below. We'll do our best to answer those for you. We'll try to leave a link to all the product we've talked about here down in the description. And yeah, that's pretty much it. So don't forget to like and subscribe.